Okay, so last week we talked about the derivative of the function e to the x, the natural exponential function. Today we're going to be talking about the derivative of the natural logarithm, okay, which is the natural log of x. I could go into the big long proof about it. We don't really have time to do that, but I will just tell you that the derivative of the natural log of x is just 1 over x, okay? Now it gets a little bit more complicated when it's not just the natural log of x, okay? In fact, if it's the natural log of something other than x, let's call it u, all right, then we would have 1 over u, but remember the chain rule, it's the derivative of what's inside, so you'd also have to multiply by u prime, okay, the derivative of whatever u is, okay? So we're going to look at a few examples here doing just exactly that, okay? If you have y is equal to the natural log of x to the third plus 1, well, you then would take y prime is equal to, all right, so 1 over that x to the third plus 1 times the derivative of what's inside. Well, what's inside is x to the third plus 1. Derivative of that would be 3x squared, okay? All you have to do now is simplify that. All right, combine them into 1. Well, that's over 1. So when you multiply straight across, y prime would end up equaling 3x squared over x to the third plus 1. Okay, can't simplify, can't cancel anything out there. That's all it is. All right, if you have the derivative of the natural log of the sine of x, again, no different. Natural log of the sine of x. So you would start off with 1 over the sine of x times the derivative of sine, which we know is just cosine. And again, just combine them into one fraction. So that's over 1. So you have cosine over sine, which in this case, that actually does simplify. Cosine over sine, using our trig identities, is just cotangent. Okay? So the natural log of the sine of x, its derivative just equals cotangent of x. Okay, this still works if the natural log is the inside function, okay, in the chain rule. F of x is equal to the square root of the natural log of x. Okay, well, again, rewrite this as the natural log of x raised to the 1/2 power. And then now it just looks like the power rule combined with the chain rule. All right, so f prime of x would equal, okay, 1/2 times the natural log of x, subtract 1 from the exponent, so you have negative 1/2, times the derivative of what's inside, which derivative of natural log of x is 1 over x. Okay, and then you just clean it up. Natural log to the negative 1/2 power would become, okay, so you have the 1 over 2. This becomes 1 over the square root of the natural log of x times 1 over x. So cleaning it up even further, f prime of x would equal 1 over 2x times the square root of the natural log of x. All right, pretty straightforward, okay? So let's apply it. All right, here's just one example. Find the absolute minimum value. Okay, so absolute mins, critical numbers. Critical numbers occur when the derivative is set equal to 0. So first thing we have to do, find the derivative. Okay, now here, paying attention right away off the bat, you've got an f function, you've got a g function, we've got them being multiplied by each other. We have to use the product rule. So f prime of x would equal, okay, derivative of f. So 2x times just regular g, natural log of x, plus, you leave f alone, x squared, times the derivative of g, derivative of natural log of x is 1 over x. Okay, so clean it up here. We've got 2x natural log x plus, okay, you've got x squared over 1 times 1 over x. Well, that would equal x squared over x. One of the x's cancel, so you're just left with x. Okay, so that's what f prime is equal to. But we're not done there because now we're actually applying it. So you have to now set that equal to 0 and solve. So 2x natural log x plus x is equal to 0. Okay, might look confusing, but you know what? This term has an x and that term has an x. So let's factor an x out. You're left with 2 times the natural log of x plus 1. So now, all of a sudden, you've got this factor times that factor set equal to 0. That's what you want. Set each one equal to 0. X equals 0 from this one. Okay, that's one critical number. And then you've got 2 times the natural log of x plus 1 is equal to 0. Okay, well, solving for x there, you'd subtract 1. You'd divide by 2. So the natural log of x is equal to negative 1/2. Well, how do we figure out what x is equal to? Well, remember what natural log of x is. Okay, that's e. It's a base of e. So if you raise e to the negative 1/2 power, that's what x equals. Which, if you rewrite this, you would have 1 over the square root of e is equal to x. Okay, so that's your other critical number. But now we have to figure out what the actual minimum value is. So we have to plug them into our actual original equation up here. All right, so when we do that, f of 0 is equal to 0 squared times the natural log of 0. Uh-oh, natural log of 0. Wait a minute. Okay, doesn't work. 0 is not in the domain for the natural log, so that doesn't work at all. Well, that makes our job easier. So f of 1 over the square root of e would equal 1 over the square root of e squared times the natural log of 1 over the square root of e. Okay, well, 1 over the square root of e squared, well, that would just be 1 over e. The natural log of 1 over e squared, well, again, think about it. E to what power is equal to 1 over e to the square, 1 over e, oh my gosh, 1 over the square root of e. Well, for us to do that, we'd actually have to go back to this right here. So that equals negative 1/2. So when you evaluate this, you get negative 1 over 2e. Okay, so the absolute minimum value there would be negative 1 over 2e.